Hello. We're going to start with the basics, but we're going to keep it technical because I am talking to an engineering team after all. In security, you'll hear about confidentiality, integrity, and availability. It's called the CIA triad. These three principles are like the backbone of every security decision that you make. If you master how they interact, you can build more secure systems from an engineering standpoint. But what does that mean for you in terms of action points? Confidentiality is you making sure that data is accessible only to people who are authorized to see it. In practice, this means encrypting sensitive data, implementing proper access controls, and using technologies like TLS for data in transit and AES 256 for data at rest. For example, when you're storing user passwords, you use hashing algorithms like bcrypt or Argon2, but it's not just hashing, it's about salting to protect against rainbow table attacks. On the network side, we use TLS 1.2 Plus to encrypt data between clients and servers. Here's my big sister technical tip for you. Encrypt with the latest encryption standards. Outdated protocols like SSL are still floating around, but they're more vulnerable. Use tools like Qualys SSL Labs to test and verify your TLS configurations. Next, integrity makes sure that data remains unchanged and trustworthy. If someone tampers with your data, you want to know about it immediately. So to maintain integrity, use hashing algorithms to generate checksums or hash values. Every time you transmit or store data, compare the original hash with the received one. In an API request, you can include an SHA 256 checksum of the payload. When the server receives it, it recalculates the checksum to make sure nothing has been altered during transmission. Another technical tip for you is hashing alone isn't enough. Combine it with digital signatures for sensitive data. Use public key infrastructure to sign your hashes so they can't be forged or manipulated. If a hash fails, you know something isn't right. And third, we have availability, which is all about making sure that services and data are accessible when you need them. This doesn't just mean uptime, because that's the first thing that pops in my head, but also guarding against denial of service attacks, capacity overloads, or hardware failures. To maintain availability, use load balancers like Nginx to distribute traffic across servers and ensure redundancy. For disaster recovery, set up multi-region replication in cloud environments like AWS, so your data is always available, even if one region goes down. Also, you can automate failover with auto-scaling groups and monitoring tools like Prometheus. It's one of my favorite tools. These tools help you detect outages early and automatically scale your infrastructure to handle traffic spikes. Now, beyond the CIA triad, let's discuss access control. Access control makes sure that only the right people or services have access to the right resources within your system. Engineers typically use access control lists, role-based access control, or attribute-based access control, depending on the complexity of your system. As you scale, switch to attribute-based access control if your access control needs to consider multiple attributes like time of day, user location, or even device type. This gives you fine-grained control over who can access what within your system. And finally, we're going to touch on secure development practices. Security needs to be embedded in every line of code that you write, right? That's why this conversation is happening. So that means following secure coding guidelines, avoiding common vulnerabilities like SQL injection or cross-site scripting, and using security tools like SonarQube or AWS Shield Advanced for infrastructure and application level safety. Incorporate security tools like Trivy directly into your CI/CD pipeline so nothing slips through the cracks during deployment. And my final big sister advice is to use defense in depth. Never rely on one single layer of defense. A multi-layered approach to security where each layer adds its own barrier is best. Even if one layer is compromised, others stand between the attacker and your data. It's like having multiple doors in your house. If an attacker bypasses your application firewall, they'll face encryption, access control, and monitoring systems along the way. So whether it's securing data with encryption, ensuring data integrity, or maintaining availability, every security concept is interconnected. By applying these principles, you're not just securing data, you're building a more resilient system that can withstand attacks from all angles. I already know you have questions, so lay them on me in the thread.